So let's discuss about the stack. So we'll discuss what is a stack, how the stack works, and how we can implement the stack in Python using the lists. So let's discuss about what is the stack. Imagine you have a box and top of that box is open. So you can only put the things inside that box uh, from the top. Now let's create few more boxes. Let's name that as one. So we have created this four different boxes. So as the box is only open from the top side, we can only put the boxes on that opening. So we put the first box. Then we have to put the second one. Then we can put the third one. Then we can put the fourth one. So as you can see, we can only put the boxes on top of each other. So this is called a stack. So imagine a stack of books. You can imagine the stack of plates. So we can only put on top of each other. And the most important thing is we can only take out the topmost element. We cannot take out this second or first. We can only take out the topmost element from that stack. So that is why the stack is called as last in, first out. So whichever the last element which is going in the stack, that is the first to come out, or we can access that one, that last one. That is why it is called as last in, first out. It's called as LIFO. This is the stack. This end is one. So now let's look at the operations that we can perform on the stack. So as you can see, the first one is we add the elements in the stack. This is called as push. So essentially, we are pushing the elements or pushing the data on the stack. So this is called as the push operation. So first one is push. Second one is we can only remove the topmost element, or we can only access the topmost element. So it is called as pop. So removing the element is called as pop. Then we can also check which element is currently on the top. So that is called as peak. So what is the difference between pop and peak? Peak only checks the element. It does not remove it. It only checks whichever the element is on the top. It does not remove the element. Pop removes the element and then returns the element. Whatever the data inside that element is, it returns that data. And then we can also have size. So how many elements are there in the stack? We can return that. So these are the major operations for the stack, and that is how the stack works. So essentially, we put the elements or the data, mm, and uh, in an array or in an list, and we remove the last element from that list. And adding means appending. Appending means putting the data at the last of that array or the list. So if we imagine a list, and now suppose we are putting the data inside the list. So this is the first. Let's take a look at first, second, third. Okay. So we are putting the data. We'll put the first. Then we will append. Append means we'll add after the first one. Then the third one. Then the fourth one. And for popping, what we will do is we will remove the last element and we will return it. That is called as pop. So this is how we can implement it using an array or list. So let's see the Python implementation. So let's create a class called a stack. So we have to define a constructor. Self is a mandatory argument. So we can put self dot stack is equal to an empty list. Then first operation is push. So we can define that, and to push we have to have some data as argument. So we can take data as argument, and then what we are doing is we are just doing self dot stack dot append, and then we are appending the data. Now you might ask, oh, how we can access the append. So here is the answer. We are using the list for the stack. So this is the list method. So we can access this append method. Mhm. Then we can define the pop method. Here we don't need any argument because we are just removing and returning the last element. So return, what we are returning is cell dot stack dot pop. So what the pop does is it removes that last element and it returns it. So we are returning the same. But before that, we cannot pop from an empty list. So we have to have a method to check if that list or that stack is empty. So we can define it. So pay attention here. What we are doing is we are negating the bool method. So what this method does is if the stack is completely empty, it will return false. So if the stack is empty, here we have to return true. If it is non-empty, we have to return a false. So we are just negating that here. So if cell dot with empty, then we have to return stat is empty. Okay. Then the next method is peek. So as we have already discussed, the peek does not remove the last element. It just let us know which element is on the top. So here we will again check if the stack is empty. We will return that it is empty. Then if it is not empty, then we return self dot stack the last element. So this is called as negative index. So indexes of the list starts from 0, but if you go from here, then they also starts from -1. So -1, then -2, like that. But you go from this way, like this is for this way. If you go from this way, then they start from 0, 0, 1, like that. So let's get back to our code. So this is the peak method. I think we are done. Mm, this is done, pop is done, peak is done, size size is running. So let's implement that as well. Size. So we will just return len dot start. So it will just return the length of this uh, list. So we can use the len method, and you can we can just return the length of the list, which is length of our stack. So now let's instantiate this stack. So st equal to stack. Now let's append few element. St dot push 1, st dot push 2, 3, 4. So what we did is, so those elements were out. So we just put, or that is called as push. We just push the elements on the stack. And if you want to see the list view, that is here. So you just push the data onto the stack. Now we'll print the stack, print st dot. So this is before the pop. I'm just using a f string to print. Then we'll do st dot pop. So this will be to call the pop because it is a method. So this will be after the pop. So we have instantiated the stack. We have pushed 1, 2, 3, and 4. and then we are just printing it essentially, and then again we are popping one element and we are again printing the stack. But before that, we can also print the size. So we print size of the stack, that is history dot size, and we can also pick the last element. So we can also print peak, sorry, history dot p. So it will return the last element, but it will not remove it. So before the pop and after, so here we can check if the peak removes it or not. So let's run this. Oh, we got an error. So if not bull, so let's run. Here is wrong. Just have to return. Save it and run again. So here we can see before the pop, there are one, two, three, four. Then size is also four. So here we can, maybe we can put an string. So size, this will be the P. Okay. So let's run this. So we can see before the pop, there are four elements, one, two, three, four, and size is four. Mm, one. Yeah, size is four, then peak is four, then before the pop, there are again four elements showing, and after the pop, there are only three elements. So this is how we can implement this stack using the list. We will also learn the linked lists, and we will also implement the stacks in the linked list as well. So that's it for today. Thank you.